So this is the third type of convergent plate boundary. It's the third type of collision whereby we have a continent colliding with a continent. And the first thing that I will say is that before a continent collides with a continent, an ocean collides with an ocean. So you can imagine two continents really far away from each other. In the middle there would have to be a lot of ocean. So you would actually have an ocean-ocean collision, just like we see in the Philippines or Japan or the Aleutian Islands, and that would take place for a long time. So you would have your island arc volcanoes, subduction, all taking place, just like we discussed in collision number 1. However, there would be a point in time whereby that ocean floor would be pretty much destroyed and fully subducted, and the two continents would be right up against each other. And the minute when the two continents get up against each other, neither continent is able to be subducted because the density of continents are so low. So in this particular case, when Asia and India collided to form the Himalayan mountains, Asia couldn't go down because it's a low-density continent. India couldn't go down because it's a low-density continent. So essentially what happened is that subduction stopped altogether. And when the subduction stopped, there was no magma, so as a result, volcanoes in this particular environment also stopped. However, the two continents, they each had a continental shelf, and the convection currents were still moving the two plates towards each other, so Asia and India were still moving towards each other, and that put the continental shelves under a lot of compressional force. And as a result, the two continental shelves got pushed together and pushed up high into the sky, creating a really, really big mountain range called the Himalayas. The same thing actually took place in western Newfoundland to create the Appalachian Mountains. However, the Appalachian Mountains are long since gone, or almost gone, I should say, due to a lot of weathering and erosion. In this particular diagram, you would get a lot of regional metamorphism at the base of these mountains because the rocks are so deeply buried, the pressure and the temperature is really high along with hot chemical fluids. So we discussed earlier how you could have sedimentary rock called shale that could become slate, that then could become phyllite, that then could become schist, that then could become gneiss. So this is a continent-continent collision.